let's derive quotient rule. In other words, we were looking at quotient of two functions. Quotient of two functions, okay? And that is given as y is equal to u all over v. What we are going to do is to derive the quotient rule that can be applied any time that we are solving functions that need quotient rule formula. So without wasting time, let's just start. Okay, let me pick chalk. Now, first of all, I'm going to solve from this angle to that angle. Let's watch. The first thing we need to do is to take note of this. Any change in y will lead to corresponding changes in u and v respectively. That's what we need to take note of. So if we begin with y change to this is equal to u change to this over v also then change to dv. That's the first thing. Can you see there is a change in y here, leading to corresponding changes in u and v respectively. Okay, so with that we begin again. We now make dy the subject by removing y. How do we remove y? By introducing minus y, because this y is already a positive y. So we introduce a minus y both sides, okay? Minus y plus y is equal to, or rather, and then plus dy is equal to u plus du, okay, all over v plus dv, okay, minus y, because we are introducing y both sides, okay? If that is the case, we have succeeded in removing this, and we are left with just dy is equal to u plus du all over v plus dv, and then minus y. That is it. Minus y. Let me write my well very well. Okay. So we have this. What next do we do? We substitute. Okay? We now replace y with u over v. That's the next thing we are going to do. So we move on. Dy is equal to u plus du all over v plus dv, okay? Now minus, instead of y, we put u all over v. So we have arrived at this point. So take note of that. Remember, if you have watched up to this moment, why don't you subscribe? Give me some thumbs up. Put on the bell button for constant notification, and then share with your friends, network, and students. Okay, with that, let's move on. Look at this. We need to find the LCM of the denominators, the two denominators. We need to find the LCM, right? So let's see how the LCM plays out. We find the LCM of the denominators. So that will help us to understand this further. Okay, so the LCM of the denominators is going to be dy equal to, watch, is going to be v multiply this, and we have v bracket open v plus dv bracket close. So now we have found the LCM. The next thing is to simplify further to find the numerator. Look at it. V comes here is going to cancel v. And this is left, okay? We now use this to multiply whatever we have there. And it's going to be, take it again. If we start with, okay, let's start with this factor. This factor comes, it nullifies this. We are left with v, right? Now v will now multiply everything here. Take it again. This factor is the LCM, is going to cancel out this, and we are left with v. And then v will multiply everything there. And we now have v bracket u plus du bracket close. Remember we put our minus sign. Okay? So what comes next? What comes next is v comes, cancel out v, and we're left with this. And this will multiply everything here. And now we now have u bracket open v plus dv. Okay? Bracket close. That is it. So we have simplified using the LCM. It is time for us to collect like terms and open the brackets. We open the brackets, open the brackets, or parentheses, so to say, brackets, okay, and collect like terms, and collect like terms, That's what we need to do. That's the next step. So what do? We're going to do this up there. So let's see. By the time we begin opening the bracket, we have dy dx. Sorry, there is no dx yet. We are going to introduce that later. So we open the brackets, it becomes dy. Look at this. Look at this. V times this is going to give us uv. V again times this is going to give us v du. We put minus sign. Look at this. U times this is going to give us u v. And then u finally multiply this is going to give us, remember, this should be in, okay, minus u times this. We change this. No longer plus, it's going to be minus. It's going to be minus u dv all over. Let's see what happens here. Look at this. Yeah, let me take chalk. Let's see what happens here. V multiply v. We have v squared. V squared. Alright? We move on again. V multiply dv. It becomes plus v dv. That is cleared. Okay? We have cleared all this. And the brackets removed. It is time for us to collect like terms. Let's see how that happens, or how that works. Du is equal to, where is our like terms? Okay? Look at it. This can cancel this. uv minus uv is gone, so this is gone with this. And we are left with v du minus u dv all over v, look at this, this is v, okay, squared, plus v dv, right? Very, very interesting. Look at this step. We are almost through. So let's go further. A situation that we now differentiate. We differentiate the numerator with the y, the x. The y now goes with the x, affecting only the numerator factor. And the numerator factor is v, is going to be du over dx, all right, minus u dv over dx at this point, all over v squared plus v dv at this point. But this is not the final solution. It's not. This is not the final derivation, because we need to do something here. This is not the final derivation. We are just one more step to the final answer. So let's see what happens. If that is the case, it then means Therefore, it means as dy tends to 0, comma, du will also tend to 0. Alright? Comma. And that happens. Also leading to dv. dv tending to 0 as well. So look at it. We must observe this. So the last one is where our interest lies. dv tends to 0 to remove this. So what do we do next? It means now we have understood this, we need to clear off this. Okay? We clear off this to have enough space. And we're going to have dy dx is equal to v du dx minus u dv dx, okay? All over v squared plus v. Instead of writing dv again, we have been told, or we have concluded that dv tends to 0. As this factor as well tends to 0, right? But our interest is dv tending to 0. So we now replace dv with just 0 and close it. Let me take check. We are arriving at the final answer. Alright? So with this, we can clean off this as well. We don't need this again, because we have learned this. Now, so what happens? This is over. This will vanish. And then we have, it implies that dy dx is equal to v du dx, alright? Minus u dv dx, alright? All over. Watch out. This now becomes completely 0. This becomes completely 0, and we left with just v squared. Proved. So we have succeeded in deriving the formula for quotient of two functions. And this is called quotient rule. This formula is called quotient rule. So, in case you want to solve two functions using quotient rule, you must understand the steps involved in solving such a question. That's what it means. Alright, so having watched up to this moment, I want to thank you so much for your patience and for watching up to this moment. But before I let you go, thank you my returning subscribers, my new subscribers. You guys are so amazing. Please subscribe. Give me some thumbs up. Put on the bell button for constant notification. And then don't forget to share with your friends, networks, and students. I am signing out now. Thank you.